All right, today is lesson 3.4 continued. We're going to do the second half of it, and today is the power of a quotient. So I'd like you to fill in your notes with what I have here. The expanded form of what you get with x over y to the fourth power. That equals x to the fourth power, because this has an assumed 1. The y has an assumed 1. 4 times 1 would be your 4. Y to the 1 times 4 also is to the fourth power. So to find a power of a quotient, you have to find the power of the numerator and the power of the denominator. And then you divide or simplify if possible. The algebraic model, if we have a divided by b to the m power, that means when you multiply, you have a to the m power over b to the m power. And this only works if b is not equal to 0. Like 6 divided by 0. Not possible. You can't do that. You can't divide by something that doesn't exist. Alright, so if you need more time, just pause it at this point and finish writing this down. Alright, go on to do some examples. Now we have, I want to make this a little bit bigger. We have 1/2 to the fourth power. So, even though they're not there, they have the assumed 1 exponents. So that's going to equal 1 times 4, 1 to the fourth power, over 2 to the 1 times 4 also is the fourth power. And on your worksheet today, it's a review worksheet. It's not in your packet. You leave all your answers in exponential form. So this would be your final answer. You don't need to make that equals 1 to the fourth power equals 1. 2 to the fourth power would equal 16. You don't need to simplify that. You can leave all your answers in exponential form. All right? Now over here for b, that would equal x to the second power, 1 times 2 is 2, over 5 to the, 5 has an exponent of 1, times 2 to the second power. That would be your answer left in exponential form. We cannot simplify that as far as the exponents and the variables anymore. Letter C. Here, x to the 1 times 8, so we have x to the 8th power over y to the 1 times 8, y to the 8th power. I cannot subtract these because they're not like terms. This is an x, this is a y. Now, over here when you have a negative, when we have a negative, we always want to assign it to the numerator. So we would rewrite that as a negative 2 over 3. Assign that negative to the numerator, and now let's simplify. So a negative 2 to the 1 power, we're going to have a negative 2, 1 times 3 is to the third power, all over 3 to the 1 power, 1 times 3, 3 to the third power. Now, do you need to have the parentheses around the negative 2 here? Well, in this case, it wouldn't make a difference because that would be negative 2 times negative 2 times negative 2. Negative times a negative is a positive times a negative. Your answer would be negative anyway. 2 times 2 is 4 times 2, you would get a negative 8. Same if we didn't have the parentheses, a negative 2 to the third power. That would be a negative times 3 2's. So that's a negative assumed 1. That's like negative 1 times 2 times 2 times 2. So 2 times 2 times 2 is 8 times the negative 1. You'd still end up with the negative 8. So see, whenever you have an odd exponent, I'm not going to count it wrong if you have your parentheses there, but in this case, you actually wouldn't need them. You could also write this as a negative 2 to the third power over 3 to the third power. When you have an even exponent, though, then it matters if you have parentheses or not, because that'll make a difference between a negative and a positive answer. Now, when you write this out, that's like 3 times y all over 2. to the 5th power. All right, so these all have their assumed 1 exponents. So that's going to equal 3 to the 1 times 5, 5th power, 1 times 5, y to the 5th power, all over 2 to the 1 times 5, 2 to the 5th power. All right? When these aren't like terms, 3 to the 5th, the 2 to the 5th, so I can't simplify. Leave it in exponential form. All right? xy divided by z, that's like x times y. They're each a factor over z to the 7th power. All right? So they each have their assumed 1s. So that's going to equal 1 times 7. We're going to have x to the 7th. 1 times 7 for the y to the 7th, all over z to the 1 times 7, z to the 7th. And that would be our final there. Now, simplify each expression, leave answers in exponential form. Now, here, I'm going to write it a little bigger. Those are separate factors, all to the 3rd power. Now, instead of putting our assumed 1s, they're telling us we have x to the 9. Well, what is 9 times 3? That's going to be x to the 27th power. Now, y, we have 2 times 3, so it's going to be y to the 6th. That's what that turns out to be. Same for down here. Sometimes you like to write it out like 2 times x to the 10th, all over x to the 7th. All this to the 4th power. Some people like to write it out with their factors and a times sign between it so they don't forget. A lot of people like to put their assumed 1s in there for those that haven't been assigned an exponent. Now we can simplify. 4 times 1. Now I have 2 to the 4th power. And then x, 10 times 4. We've got x to the 40th. All over. Now I have x to the 7th. Don't forget about that one. We have to also take x to the 7th times 4. So it's going to be x to the 28th. Now don't think we're done here. There's some simplifying in this situation that we can do. We have like terms here. X's. We have x to the 40th divided by x to the 28th. And when we divide, we subtract our exponents. So 40 minus 28, those all cancel out, leave me with 1. 40 minus 28 leaves me with 12, an exponent of 12 up here. So now what do I have left? I still have my 2 to the 4th power, and I now have my x to the 12th power all over, well, this is 1. And we said earlier, when 1 is your denominator, you don't need to write it like that. You just need to write it as 2 to the 4th power, x to the 12th. And then you're done. All right. Again, some like to write it bigger. 4 times x times y to the 5th, all over 2. And those assumed 1s that aren't in there. Now we do our multiplying. 1 times 2, so we have 4 to the 2nd power. 1 times 2 is 2 again, so x to the 2nd power. And now the y. 5 times 2, we have 5 to the 10th power. Left in exponential form. Now here, look at this one. This was like the one that we had in our worksheet that was 5 times 3 to the 4th power or something like that. We can simplify this. These are like terms. I can make that into 15 to the 4th power. So that equals 15 to the 4th power. That was a correct answer. Some of us went 5 to the 4th power times 3 to the 4th power, which would be the same. Now if you look at this, we can combine these, or we can multiply these. See that multiplying sign? So let's multiply. Negative 2 times 3 gives me negative 6. Now I have my x's. X to the 7th times x to the 2nd. Now these are going across, we're multiplying these two, so we add them. We're going to have x to the 7 plus 2 is 9th power. And now we still have this all in parentheses and it's still to the 3rd power. So what we did is we simplified by multiplying these first. Now we're going to do our power to a power again. So our assumed 1 here in the 6, don't forget it, that's separate. So we have a negative 6. 1 times 3 is 3 to the 3rd power. X to the 9 times 3 is 27. Now in this case it's an odd exponent, so do we need the parentheses? No, because we know our answer is going to be negative anyway. So actually you could rewrite this one as negative 6 to the 3rd power, x to the 27th power. However, I wouldn't count this wrong. Alright? And the last one. We have x to the 6th, y to the 2nd. So 6 times 5 is 30. X to the 30th power. And y to the 2 times 5 is 10th power. All over. Now don't just say 3. It's 3 to the 1 power. 1 times 5. So it's 3 to the 5th power. So it's x to the 30th, y to the 10th, all over 3 to the 5th power. All right, and then your assignment is to do your review worksheet for tomorrow.